have my 2, and I need it. So I'm going to write 1/2 times 2 sine of 15 degrees cosine of 15 degrees. I do know this is a 15 here, not some Greek letter. So that's going to be 1/2 times the sine of 2 times 15, right? Because the sine of 2a, 2 times 15 is 30. And the sine of 30, we can simplify this one. Anytime I give you an angle, you can actually simplify it. So sine of 30 is 1/2. 1/2 times 1/2, which is 1/4. Number 9 says the sine squared x minus 1. There we go. Sine squared x minus 1. Well, first and foremost, sine squared x minus 1. I don't have that anywhere. The closest thing I do have is this, and that just has the chance of getting really complicated. If you wanted to, at first, you could try pulling out a 1/2, but it won't fit because it's supposed to be a 2. So if you try and change this, it's going to alter itself to a point we can't use an identity. So let's try something different. For sine squared x here, like before, let's try putting in 1 minus cosine squared x. How about that? Instead of sine squared, how about 1 minus cosine squared? And then look at what happens here. Your 1's will go away. You got a positive 1 and a negative 1. And it leaves you with negative cosine squared x. So that one is a little different as far as this lesson goes. So let me just spend a moment or two explaining that. When I saw number 9, I looked at it and said, is it one of my identities on the front? On this sheet particularly. And it's not. It's close, but I need a 2 in front of here. But if I do that thing up here, where I had to put a 2 and compensate with a 1/2, that's going to change 1 to 2 as well. That's not an identity, so that's not going to work. All right? So I said, well, let's just do something different. Let's change that to 1 minus cosine squared, and then simplify. Okay? Let's go down here to the bottom. It says, use the information given about the angle to find the exact value of sine 2 theta and cosine 2 theta. Okay. Here's the interesting part. We're going to start off. It says tangent of theta is -3. And if there's anything I know about tangent, it's going to be over 1 here. Y over x, remember. And it's somewhere between pi over 2 and 3 pi over 2. So let's draw a picture. Picture. First, it says that tangent is negative, and it's somewhere between pi over 2 and 3 pi over 2. Well, here's pi over 2, and here's 3 pi over 2. Well, that covers quadrants 2 and quadrant 3. Well, which one of them is a tangent negative in? Well, it's negative up here. So let me ask you a question real quick. If tangent of theta is y over x, which in this case happens to be 3 over 1, which one of those is going to be negative in the second quadrant? It's going to be your x value, isn't it? It's going to be your x value. So you got a -1, you got a 3. Okay, so before we go any farther, let me say this. You have got to use common sense. And common sense tells you that you must check to see which one is positive in which quadrant. In this case, you're dealing with tangent. It happens to be positive, or tangent happens to be negative in quadrant 2. that means your x value is negative, okay? Don't just assume because it says it's negative 3 that the negative goes with the 3, okay? So on here, little Pythagorean theorem, 1 squared plus 3 squared is 10 squared, right? Or excuse me, 1 squared plus 3 squared is 10, and then you take the square root of that, so square root of 10. Just losing a little bit of Pythagoras here. So for part A, find the sine of 2 theta. So that's going to be sine of 2 theta is 2 sine theta cosine theta. Now I can't just, I wish I knew theta. Here's theta. I wish I knew theta so I could just multiply it by 2 and call it a day, but I don't, so I won't. The sine of theta is y over x 2 times, or excuse me, y over r, 3 over the square root of 10. Cosine is x over r times negative 1 over the square root of 10. Which is, remember this is 2 over 1, so it's 2 times 3 times negative 1, which is negative 6, over square root of 10 times square root of 10 is 10, which is negative 3 over 5. So again, after I got it drawn, everything else was a piece of cake. It's just plugging in. B, cosine of 2 theta. Now on this one, you can pick which one you want to do. It's completely up to you, and it'll give you the same thing every time. I will say that the one I like to use the most is cosine squared minus sine squared, and that's only because you're squaring everything. Cosine squared theta minus sine squared theta. I like it because you're squaring everything. That comes in handy when you do negative 1 over square root of 10 squared minus 3 over the square root of 10 squared, because that changes it into 1 over 10 minus 3 squared is 9, square root of 10 squared is 10, which is negative 8 over 10, which is negative 4/5. Run back and watch those if you need to one more time. I'm just going to speed up just for the sake of time here. Verifying that an identity is the same. First, we've got a 1 minus cosine of 2x over sine of 2x. Okay, so here's what I'm going to do. I'm going to start out by simplifying the top here. So do I have a cosine of 1? Oh, goodness. Or a 1 minus cosine of 2x? No, I don't, because all my cosines are squared here, right? So that's not going to work. So here's what I'm going to do instead. I'm going to change cosine of 2x. I think that's supposed to be, yeah. So I'm going to say cosine of 2x is going to be one of these things. I'm sorry, I was going the wrong way. Cosine of 2x is going to be one of these. Now, which one is the key? So if you'd flip to the back of your paper real quick, I'll keep this up here so you can see it. Flip to the back of your paper and look at it. It says 1 minus cosine of 2x over sine of 2x. I want this thing in terms of sine and only sine to try and cancel something out with that sign. Here's what I'm going to change it to. 1 minus 2 sine squared a. So I'm going to choose this middle one because my denominator is starting off with sines. Probably a good bet I'm going to be canceling something out here. Now that's only a guess. If it doesn't work, I can go back and redo it. So let's change the top here to a 1 minus, and I'm going to plug in here 1 minus 2 sine squared x all over. And what about sine of 2x? Well, I know from the front that's going to be 2 sine x cosine x equals tangent x. On the top we've got a 1 minus 1. Well, that's handy. 1 minus 1 right? Now this negative would also make this a positive 2 sine squared x. Don't forget to distribute your negative. And then you've got 2 over 2. Let me rewrite this for you real quick. 2 sine squared x over 2 sine x cosine x. And go cancel McHappy-Smith on it, and you get 2 and 2 will cancel. Sine squared, so one of the signs on the top and the sign on the bottom will cancel, and you end up with sine x over cosine x, which is tangent x equals tangent x. Okay? If you need to, pause the video, backtrack, watch again. Again, what I'm doing here is I'm substituting in something for cosine 2x. I just picked the middle one because I know I'm going to be wanting to cancel some of these signs out. If you wanted to pick the other ones, you can, and it may be a couple more steps, maybe a couple less steps. Who knows? We may explore that a little bit in class.